Your check engine light just flashed on, but here's what your mechanic won't tell you. That tiny camshaft position sensor could mean a $50 fix or a $3,000 engine rebuild. I'm about to show you 7 warning signs most technicians miss, plus the exact 20-minute DIY replacement that could save you thousands. Look, I've been working on engines for over 15 years, and nothing kills performance faster than a failing camshaft position sensor. This little component about the size of your thumb sits near your camshaft and sends critical timing data to your engine's computer every millisecond you're driving. When it starts going bad, your ECU loses track of when to fire spark plugs and inject fuel. Here's the scary part. Modern engines rely on split-second precision. We're talking about timing measured in degrees of crankshaft rotation. Lose that timing by even a few degrees, and you'll see misfires, stalling, and in worst cases, bent valves from piston to valve interference. Just 3 months ago, I helped diagnose a 2018 Ford F-150 that started with what seemed like a simple rough idle. The owner ignored it for 2 weeks. By the time it came in, the timing was so far off that the engine needed a complete rebuild. Total damage was $4,200. But here's what gets me fired up. This could have been prevented with a $40 sensor and 20 minutes of work. Your camshaft sensor works by detecting metal teeth on the camshaft's reluctor ring. As these teeth pass by the sensor, they create electrical pulses that tell your computer exactly where each cylinder is in its cycle. When this signal gets weak, intermittent, or stops completely, chaos begins. Think of it like this. Your engine is an orchestra and the camshaft sensor is the conductor. Without that precise timing, every musician plays whenever they feel like it. The result isn't music anymore, it's noise. And in your engine, that noise translates to poor performance, wasted fuel, and eventually catastrophic damage. What makes this particularly dangerous is how these sensors fail. They don't usually quit all at once. Instead, they deteriorate gradually, sending increasingly unreliable signals. Your engine computer tries to compensate, but eventually it can't keep up. That's when you start seeing the warning signs I'm about to share with you. I'm counting these down from 7 to 1 because the last one is the most dangerous and the one that could leave you stranded in traffic. Warning sign number 7, intermittent check engine light. This is the sneaky one. Your check engine light flickers on for a few days, then disappears. Most people think, great, problem solved. Wrong! An intermittent check engine light with P0340 through P0349 codes usually means your sensor is dying slowly. The connection might be corroded or the internal components are failing under heat stress. Here's the test. When your light comes on, scan for codes immediately. Write them down. Even after the light goes off, those codes often stay in your computer's memory as pending or history codes. I always tell people to scan twice, once when the engine is cold, once when it's fully warmed up. Camshaft sensors often fail differently at different temperatures, and this simple test can catch problems before they strand you. Warning sign number 6, cold start problems. This one stumps a lot of technicians. Your engine cranks normally but refuses to start when it's cold outside. Once it finally catches, it runs fine. Cold weather amplifies sensor problems. As metal contracts and electrical resistance changes, a weak sensor signal can drop below the threshold your ECU needs to properly time fuel injection. I remember working on a Honda Accord last winter. The owner said it started fine in her heated garage but wouldn't catch in store parking lots. We found the camshaft sensor connector had moisture inside. Every cold morning, condensation would interrupt the signal. The fix was dielectric grease on the connections and a new sensor. Total cost was $65. She was about to trade in the car for $8,000 less than it was worth. Warning sign number 5, acceleration hesitation. Feel that stumble when you press the gas pedal, especially between 30 to 50 miles per hour? That's your engine computer getting confused timing signals. When camshaft sensor data becomes erratic, your ECU can't properly advance ignition timing during acceleration. Instead of smooth power delivery, you get fuel delivery gaps that feel like the engine is fighting itself. This isn't just annoying, it's dangerous. Hesitation during highway merging or passing can put you in harm's way. Plus, that erratic fuel delivery is wasting gas and creating excess emissions that could fail your next inspection. Warning sign number 4, RPM-specific rough idle. Here's a diagnostic clue that separates amateurs from professionals. Your engine idles rough, but only at specific RPM ranges. Most people notice this around 800 to 1,200 revolutions per minute. The engine shakes, the steering wheel vibrates, but rev it up or let it drop down, and everything smooths out. This happens because camshaft sensors often have dead spots in their signal pattern. As the reluctor wheel rotates, certain positions don't generate clean pulses. At idle, your engine spends more time in these problematic positions. The sound is distinctive too. Instead of a steady purr, you'll hear an uneven rhythm that sounds like the engine is struggling to maintain consistent timing. Warning sign number 3, transmission problems. This surprises people, but your transmission depends on camshaft timing data for proper shift points. Modern automatic transmissions use engine load and timing information to decide when and how firmly to shift. Bad camshaft sensor data confuses the transmission computer, leading to harsh or delayed shifts, getting stuck in second gear, slipping between gears, and transmission error codes in the P0700 series. I've seen customers spend $1,500 on transmission diagnostics only to discover a $50 camshaft sensor was the real culprit. The transmission was protecting itself by going into fail-safe mode, which is why many people end up with expensive transmission repairs when a simple sensor replacement would have solved everything. Warning sign number 2, sudden fuel economy drop. When your camshaft sensor starts failing, fuel economy can drop 15 to 25% seemingly overnight. Here's why. Your engine computer relies on precise camshaft position data to time fuel injection. When that signal degrades, the ECU defaults to safe mode fuel maps that run richer to prevent engine damage. Plus, mistimed injection means unburned fuel gets wasted through the exhaust system. You're literally throwing money out your tailpipe. Track your miles per gallon for a few fill-ups. If you normally get 28 mpg and suddenly drop to 22 or 23 mpg with no change in driving habits, suspect sensor problems. This is often the first sign people notice, and it's your wallet telling you something's wrong before major damage occurs. Warning sign number 1, random stalls while driving. This is the most dangerous symptom, and it happens without warning. You're cruising along normally, then suddenly complete power loss. The engine dies, power steering becomes heavy, brake assist disappears, you're coasting to a stop in traffic. When camshaft sensors fail completely, your engine computer can't determine piston position. It shuts down fuel and ignition to prevent catastrophic damage. While this protects your engine, it creates a serious safety hazard. Always pull over safely if this happens. Don't attempt highway repairs. This is the warning sign that means your sensor has moved from failing to failed, and continuing to drive risks not just expensive repairs, but your personal safety. Now let's diagnose this like a pro. You'll need 4 tools, and I'll walk you through the exact process that professional technicians use. First, an OBD2 scanner. Minimum $30, but I recommend models with live data capability if you're serious about maintaining your own vehicle. Second, a digital multimeter. The Harbor Freight version works fine for this, around $15. Third, a basic socket set, usually 8mm, 10mm, or Torx bits depending on your vehicle. Fourth, safety equipment. Gloves and safety glasses are non-negotiable when working around running engines. Total investment is under $80. Compare that to $150 or more in diagnostic fees at most shops, and you can see why learning these skills pays for itself quickly. Step 1. Code verification. Connect your scanner and pull all codes. Don't just look for camshaft codes. Check for related issues that might point to wiring problems or multiple sensor failures. Common camshaft position sensor codes include P0340 for circuit malfunction, P0341 for range or performance issues, P0342 for circuit low input, and P0343 for circuit high input. Here's the professional trick. Clear the codes, drive for 10 to 15 minutes, then rescan. If the codes return immediately, you've confirmed the problem isn't intermittent and you're dealing with a hard failure. Also check for crankshaft position sensor codes in the P0335 to P0339 range. These sensors work together and failure of one can trigger codes for both, which can lead to misdiagnosis and unnecessary repairs. Step 2. Voltage reference testing. This step eliminates wiring problems before you replace the sensor, which could save you from buying parts you don't need. With the key on but engine off, back probe the sensor connector. You should find 3 wires. Reference voltage should be 5 volts, sometimes 12 volts on older vehicles. The signal wire will vary from 0.5 to 4.5 volts. Ground should be less than 0.1 volts. If you don't have proper reference voltage or ground, the problem is wiring, not the sensor. Replacing the sensor won't fix anything, and you'll be back to square one with the same symptoms. Look for corroded connectors, chafed wires, or loose pins. Water damage is common in engine compartments, especially around sensors that are exposed to road splash and engine heat cycles. Step 3. Signal output testing. This is the definitive test. With the engine cranking, the signal wire should show a clean square wave pattern switching between low voltage at 0.5 volts and high voltage at 4.5 volts. Set your multimeter to DC voltage and watch the reading while someone cranks the engine. You should see the voltage pulse rapidly and consistently. No pulse means dead sensor. Erratic pulse means dying sensor. Clean, consistent pulse means the sensor is good, and you need to look elsewhere for your problem. Some scanners can show this as a live data stream. Look for camshaft position sensor signal and watch for consistent switching. This real-time data can reveal intermittent problems that might not show up during static testing. Safety first. Park on level ground, engine off, emergency brake set. Disconnect the battery negative terminal to prevent electrical damage during the repair. Sensor location and removal. Camshaft sensors are usually located near the camshaft timing cover in the distributor housing on older vehicles or on the cylinder head near valve covers. Remove any covers or air intake components blocking access. Take photos before disconnecting anything. You'll thank me later when you're putting everything back together. Disconnect the electrical connector first, press the release tab, and pull straight out. Don't twist or yank, as this can damage the connector pins. The sensor itself is typically held by 1 or 2 bolts. Remove these carefully. Dropped bolts love to hide in impossible places, and fishing them out can turn a 20-minute job into a 2-hour nightmare. Inspect the old sensor for metal shavings, oil contamination, or physical damage. These clues help prevent repeat failures and can point to other problems that need attention. Installation best practices. Clean the mounting surface with brake cleaner. Any debris can affect sensor positioning and air gap, which will cause the new sensor to fail prematurely. Install the new sensor hand tight first, then torque to specification. Over-tightening can crack the sensor housing. Typical torque is 10 to 15 foot-pounds, but always check your service manual for the exact specification. OEM sensors are worth the extra cost. I've seen too many comebacks with cheap aftermarket units that fail within months. When you're already doing the work, spending an extra $20 for a sensor that lasts years instead of months is money well spent. Apply a thin coat of dielectric grease to electrical connections. This prevents corrosion and moisture intrusion, which are common causes of premature sensor failure. Post-installation verification: reconnect the battery and start the engine. It should start normally and idle smoothly. If it doesn't, double-check your connections and make sure you didn't disturb any other components during the repair. Monitor the check engine light for the first few minutes. If it stays off, you're on the right track. Some vehicles may need to relearn idle parameters, so don't panic if the idle is slightly rough for the first few minutes of operation. Take a 10-minute test drive, including city and highway speeds. Pay attention to idle quality, acceleration response, and shift feel. All of these should return to normal with a properly functioning camshaft sensor. Rescan for codes after the test drive. A successful repair should show no camshaft-related codes. If codes return immediately, you may have a wiring problem or another related component that needs attention. Regular maintenance prevents most sensor failures. Change your oil on schedule. Dirty oil creates heat and contamination that kills sensors over time. Inspect electrical connections during routine maintenance. A $2 can of electrical contact cleaner can prevent $500 in diagnostic time and unnecessary repairs. Here's the cost comparison that should motivate you to pay attention to these warning signs. DIY repair costs $40 to $80 for the sensor plus supplies. Shop diagnosis and repair runs $250 to $400. But if you ignore the problem and it leads to engine damage, you're looking at $2,000 to $5,000 in repairs. The math is simple. 20 minutes of your time can save thousands of dollars and prevent the frustration of being stranded with a broken down vehicle. These 7 warning signs can save your engine and your wallet. Don't ignore intermittent problems. They always get worse, and catching them early is always cheaper than waiting for complete failure. If you caught value from this breakdown, hit that like button and share this with someone who needs to see it. Your next video should be about crankshaft position sensors. Click the link on screen to learn why confusing these two sensors costs drivers over $1,200 in unnecessary repairs. Subscribe for weekly automotive insights that keep your car running strong and your money in your pocket. Drive safe, and I'll see you in the next one.